Hello all, welcome to this presentation of a case study involving unexpected corrosion of stainless steel tubes by cooling water. Mm. Uh, this has happened in an ammonia cooler. Ammonia in a compressor gets slightly heated and that needs to be cooled by cooling water. So what you see is a series of two shell and tube coolers. The cooling water enters the inlet uh, of the B cooler and then comes out with slightly increasing temperature in the A cooler top outlet. You can see the arrow points, inlet and outlet. That's a cooling water. Uh, so in a short period of a few months, a leakage occurred on stainless steel tubes. So this is a service. Uh, this is for CO2 coolers. The material of standard 304 stainless steel, which is a common stainless steel, very often used. The shell side is a CO2 solution, which needs to be cooled from 94 to 45 degrees centigrade, and this cooling is affected by running cooling water on the tube side. The cooling water enters at 35 degrees centigrade, takes the heat from CO2 and then cools heats gets heated up to 42 degrees centigrade. The leak history is 10% of the tubes in the A side. That means after assuming certain heat, started leaking. So this is the appearance on the outside surface of the leaked tubes. You can see a crack-like defect here on two adjacent tubes, and you'll see more of this in the next slide. And this is the inside surface of the same position as seen in the previous slide. This is the inside surface. You can see a lot of corrosion taking place and also the point of leakage as though it is a crack. It is really not a crack. The corrosion thin down and then thinning leads to crack. Mm. This is the detail of the inside surface and the outside surface. This outside surface is a CO2 gas and that doesn't corrode. The inside surface is the water which got corroded and which leaked. The next slide will show the detail of the microstructure. This is the inside surface. It's a very typical of uh, grain boundary precipitation of carbide, and this is so there is some kind of a carbon pickup has occurred. This is a sensitized microstructure. That means carbide precipitation has occurred in the grain boundary, which are looking dark. And this is the outside surface. It's a standard austenitic stainless steel surface. The outside surface is not affected, and this is the outside surface is seeing the CO2 gas, whereas the inside surface has seen water, which is corrosive. So this is the blow up of the inside surface. You can see the corrosion slowly entering into the grain boundary and making the structure weak, and slowly one of these will lead to a crack. So, so the difference between the inside and outside surface is clearly seen. There is a carbide precipitation on the inside surface, and this is the inside surface far away. This is a far away from the leaky spot. So that means this is a standard microstructure of the tube supplied. This is the microstructure which is representative of the entire tube supplied. So this is the where sensitization has occurred very clearly. You can see the carbon pickup from the inside surface, which is slowly reducing to the body of the tube where the structure is normal. So there is a contamination on the inside surface where water is flowing. So this is a spectrochemical analysis of the surfaces. You can see the carbon content. The outside surface is okay because 304 stainless steel should have 0.08% carbon maximum, so 0.32 is okay. But whereas inside surface is very high, the carbon surface is very high, so that means carbon pickup. It is much more than the maximum allowed 0.08 and 0.12%. You can look at the chromium, it remains same. So there is basically the stainless steel is okay with respect to chemical composition except this carbide pickup here. Uh, so this is the diagnosis. Carbon contamination on the inside surface. The carbide precipitation around the grain boundaries close to the inside surface. Because there is an excess carbon, the carbide forms and precipitates, and this will remove the chromium. Hence, intergranular corrosion from the inside surface. This has happened because the chromium is used to make the carbide, and these are the areas where chromium is not there. So intergranular corrosion from the inside surface has taken place. Progress along the grain boundaries leading to leaks. So this is in summary. This is sort of a metallurgical defect. That's why it is called metallurgy-induced corrosion. Mm. The remedial measures is ensure that carbon percentage is same both on the inside surface and outside surface, and it should be less than 0.08 on the both sides. Ensure that the tubes are resistant to IGC. IGC means intergranular corrosion. They will become resistant once this carbon percentage is under control. So, in order to ensure that this should not happen in the future, propose IGC test as a mandatory test for accepting the tubes. It's a kind of quality control step. So the case is related to metallurgical defect leading to corrosion of a material like stainless steel. Thank you very much for patient hearing.